Okay, so if let's share screen and let's go to here. So as you can see in the README for today, we're going to be creating something for a restaurant database. And there's, a few entities that we can connect things with. If you guys would like to create or to pull down the restaurant database, the link to that is at the top here, and it's linked in GitHub. So what I would recommend doing is basically clone this down onto your machine, and then after that, after you've cloned into it, go into your terminal, as I've done here. I've got my setup.sh file, and then just type /setup.sh and give it a few minutes, and that should hopefully build things, and then you'll end up in the Postgres repo or REPL of your container, like so. So it builds relatively quickly, but by the time everything is said and done, you should be within restaurant. So hopefully, if you guys haven't done that yet, you guys are doing that now. Do we have any questions about pulling stuff down that we need to before we move on to talking about how we're going to design our schema? So if not, let's figure out how we're going to design our schema exactly. So if we go back to the description, it says we need to include 4 different entities. So let me go here, and you guys can all see like my Microsoft Paint right now, right? Okay, cool. So we have 4 different things. We have a customer, a dish, a price, and an order. Oh, let me move this. Okay, so let's try doing like each of these on their own. So we'll have like a customer there, then we'll have like a dish here, have like a price thing, and then like an actual order. So first of all, what are some things that we probably need to know about our customers when they're taking an order? Or in SQL, what things do we need to keep in mind for our table?
The data type.
Okay. So you would want to keep in mind the data type of specific fields, yeah. But I guess what are some specific things that customers have that we need to keep in mind when we're going to create a customer database?
Like you want their name and like any identifiable information, but also like an ID, a unique ID for each customer.
Perfect. Yeah. All right. So we need an ID. And does anybody remember what the data type of an ID is in SQL?
Integer.
Okay. Yeah, it's an integer. Or more specifically, it is a serial primary key. Thank you. So, Phil, since you answered that question correctly, would you like to be voluntold to tell us what a primary key is?
Doesn't it just automatically give you like an integer that doesn't already exist, or like at increments by 1 or something
Exactly.
like that?
Yeah, pretty much. But why do we need a serial primary key? So you're right that it forgives us like an integer that apparently counts down, but what's the point of that? So let's put in like some other fields. Let's also say we have like a name field, and that's going to be a string. Space that out. And then we could have like an email, and that's also going to be like a string or character field. So let's say now that I'm designing my customer table, right? And let's pretend that we didn't have an ID. So let's pretend this did not exist. So let's say I'm making my customer table. So I'm putting names or name, and then they get an email. So let's say that we have somebody whose name is Alice, and Alice's email is a123@gmail.com. And then we all also have, let's say, Bob, and Bob's email is b234@gmail.com. Now, let's say that Bob also has a kid, and Bob's kid's name is Bob Jr. for some reason. But when Bob Jr. puts his name in the app, he's just going to write down his name as Bob. But Bob Jr. has the exact same email as his dad. So it'll be b234@gmail.com. So if we didn't have an ID, we would not be able to tell the difference between original Bob and Bob Jr. because both their names are Bob and both of them are related to email b234@gmail.com. Actually, okay, I'm going to be back in 1 second. Something is happening, apparently. So give me like 30 seconds. Okay, so again, here we have original Bob and we have Bob Jr. I'm just going to keep that as Bob underlined. These two accounts look the exact same. Same name, same email, but they're associated with two different people. How can we determine whether they are associated with two different people or not? And that is where the ID serial primary key comes in. So if we were to create an ID field here, Alice gets an ID of 1, Bob, the first one gets an ID of 2, and Bob Jr. gets an ID of 3. Even if the name and email are the same, SQL will treat this guy and this guy as two different things because they have a different ID or a different serial primary key. So that's like the biggest benefit of including a serial primary key is it includes a way for us to differentiate between objects. And also, as I think Demand mentioned in chat, it can be used to link to other tables, which is what we're going to get to in literally a minute. So are there any questions about serial primary keys that I can answer or we keep moving on? Okay, awesome. All right, so we've got our customer class basically built out. The next thing that we need to do is make something for a dish. So for the dish, let's see, we need to know a couple of things. Let's say we need to figure out we need like the name of the dish, and that's the only thing that we need on the face of it. So what would the data type be of a dish name?
Varchar.
Yeah, so we can say it's like a string, or I guess if we want to be more SQL pedantic, we could say varchar. Now, okay, that's great. So here, let me figure out how to use the controls on Paint and a touchpad. Okay, so let's move this guy like down here, and we'll play with how we organize the tables later. Then, okay, so we've got our customer, we've got our dish, and now we're going to do price and we're going to do order. Okay, so the price one is a little bit strange, but we're just using this for this exercise because we're going to say that price is basically a category. So you could think of it being like, okay, if the dish is an entree, it's worth $3. If the dish is a main course, it's like 15. If it's on the lunch menu, it's worth like 5, something like that. So we could probably add in some characteristics for price as well. Maybe we could say like category and like dollar price, for example, or something like that. So for a category, we could give that one a varchar, char, and dollar price. Well, we would have to give it an integer or a float, but I think an integer would probably be the best thing to assign to that. And the last thing we need to do is order. Now, what are some characteristics that we should probably include for the order? I think, yeah, let me just double check. Okay, we need to figure out when the order was placed. So we could say when placed, and then that's going to be a timestamp. Okay, so am I done setting up the 4 classes? Like, is this all I need for my database?
You probably have like serial keys for each class.
Perfect. Yes. So let's go ahead and add that real quick. So also, you can have things named the same across different tables. So we can call the serial primary key ID for every single one of our tables in the database. That is not a big deal. So, okay, we've added in an ID for all of them. So what is there anything else I need to do before we start turning this into actual SQL? Or are we good? Or I guess to rephrase the question another way. Right now, if let's say that I have, a database of customers, a database of prices, a database of dishes, and a database of orders. Are these databases connected in any way?
No, we need some kind of something to link all of them together.
Yeah. So right now, I mean, these are all 4 completely different databases. They're all 4 completely different tables. They're not linked. How can we connect these things together? And that is where the fun part of today happens. Okay, so what would be a logical way to connect these 4 tables together? Let's say we start off with, let's start with the customer. Keep it nice and simple for ourselves. So I'm going to just move these out of the way. So remember, we have a customer, we have a dish, we have a price, and we have an order. So where does the customer fit into this schema? So does it make sense for a customer to be connected with a price?
No, not in this scenario.
Yeah. Does it make sense for the customer to be connected to a specific dish? Could.
If they're
Does it
available.
make sense?
Think
Does
you
it
want
make
some kind of
sense?
cart.
We could do a cart, or we also have order, and the order basically acts the same as a cart for our purposes. So does it make more sense for a customer to be connected to one specific dish or to an order that they placed that could have a bunch of dishes? I think it makes a little bit more sense for the customer to be connected with an order. Okay, so how can I specify that a customer is connected to an order? So first off, what type of relationship do we have between customers and orders?
A one
So
to
what are
many.
the Okay, so why would it be a one to many?
Because a customer can have multiple orders, but an order can't have multiple. Well, I guess it could, but each order is probably unique enough in a way.
Yeah. So for all intents and purposes right now, one person, like you can only have one name on the order, but that person can create like 100 orders. So you're right that this would be a one to many or a many to one relationship. So can anybody tell me what the 2 other relationship types are in SQL?
Isn't there like many to many and then
One to
One-to-one,
one,
but
one
it's
to
not the
many.
right lingo.
No, those are correct. So, I mean, it's the way that I would like if you're referring to it in general, there's one to one, there's many to one, and then many to many. So, one to one is like, okay, what's a good example of one to one? Like, yeah, I guess like I have one house, the one house belongs to me. Like a many to one would be like, I have many pencils, but each pencil only belongs to me. And I guess like a many to many would be something like, let's see. Like a plane has many passengers, but like each passenger is going to like many airplanes. Or a country has many people, but each country has like, or each person has like multiple citizenships, or something like that. So does that kind of make sense? Like the difference between the three? Or do you guys want to do some examples?
I think it makes sense.
Okay. Do you guys want to run through some examples, or do you guys think you're okay with continuing for now?
I guess it really comes down to being case dependent for those relationships because
Yeah.
some of the same relationships could probably have different relationships but be the same objects or whatever. So
Yeah,
I
it
guess
really
it depends on the
does.
scenario.
It really just depends on like your use case, but also just like, whatever the end user wants. So yeah, I think sometimes you will have like the exact same objects just being related to each other in different ways depending on like the setup. So I guess you could say something like if there's a place where let's say you can only place one order at this restaurant forever, like that's it. Then you would have like a one-to-one relationship between customers and orders. Or if you could have many people placing the same order, then like the direction of that many to one relationship would be like the opposite of what it is now, even though they're both still using the same scheme. So it is very, very context dependent at the end of the day. Okay, so let's see if we can get some more participation in here. So I'm going to be evil and start cold calling people. So if you don't want to be cold called, you're more than welcome to volunteer. We always welcome volunteers. If you do want to be cold called, let me know. I'm happy to do it. All right. So as Ken correctly identified, we need to create a many to one relationship between the orders and customers. So let's see, who's somebody who hasn't spoken yet? Noel. Hi, Noel. Can you tell me how we would set up a many to one relationship between customer and order?
I think you'd have to make a new column somewhere, probably as many to one, many orders to one customer. So a new column under order. Would
Okay.
just be like a customer or some kind of relationship. I don't know. And
Yeah.
then,
So let's just specify that it's customer ID. So that way, this guy goes right into here. Okay, that was not a very good arrow. Let me redraw the arrow. Perfect. So the customer ID now feeds directly into our order. Thank you very much. No. All right. So how can we tell whether this is a many to one or a one to many relationship? Because on paper, they look kind of simple. So here we can have, let's draw this out. So if we make a table of orders, we'll just call this like O, and we'll have the orders have, let's say, an ID, they have a time, and they have a customer ID. So let's say that, let's come up with like 1, 2, 3, 4, 5 orders. Some of these were placed at like 12:01. This guy was placed at like 1:34. Just typing random things in my keyboard. And we'll say this is like 12:30. Okay, so we have 5 orders. Now, because we're giving each order a customer ID, we can say that the order with ID 1 was made by customer 1. The order with ID 2 was made by customer 2. The order with ID 3, let's say, was also made by customer 2. And now we can do like 3 and 1. So what does this say? This says, if I ask you, hey, I want to find all of the orders belonging to customer 1, we would just basically look down here and see, hey, which orders have a customer ID of 1? And we see that we have 1, 2. But each of those orders only belongs to one customer. So we have, again, many orders belonging to one customer, but one customer being associated with one order. So that's how you can sort of tell I like to call the direction of the many order to one customer relationship. Now, let's imagine that it was the other way around. Let's say that we had many customers who were all making one order. In that case, how would we set this schema up differently? What would we need to change?
Would it just be like the order IDs would change in the sense that so there's many customers making one order. So yeah, the order ID would be the one that I guess would change, and then the customer, well, it'd be one customer ID and many order IDs, or is it the opposite way? One order ID and many customer IDs. I don't know. It sounded good in my head, but I don't know.
That's okay. Honestly, that's the way a lot of the SQL stuff works out. So here, let's just specify right now. This is many orders for one customer. So I'm going to just copy this and go to the other side where there's nothing. And okay, let me delete the arrow, and let's delete this. And now we want to say that this is many customers making one order. Okay, so let's think through this. If we have many customers that are making one order, would it make more sense for each customer to have an order ID, or each order to have a customer ID?
Each order would have a customer ID.
Okay, why would we want each order to have a customer ID if we have many customers making the same order?
Because even if they all order the same order, someone's going to hold the mail eventually, and so you need to make sure that hold the mail is recorded on that order ID. So it doesn't matter that they're all making the same order. They're actually all making different orders.
So
Couldn't you make,
that
couldn't you
would
make,
work. Oh, go ahead.
could you make multiple orders on the same ticket though? So like essentially like a customer would be 5 customers in one, and then that would be one order.
I suppose so. I guess this got derailed a little bit from what I was originally intending this to be, but both of you guys are correct. But the example that I was trying to say is sort of like let's say that we needed to do the opposite of what we were doing here. So here we have, again, like many orders for one customer. Like I could order like 3 cheeseburgers and a pizza, for example. But the example that I want to think of is like Alice, Bob, and Joe are all ordering one pizza.
Like they're sharing
That's-
that one pizza.
Exactly, yeah. And that pizza is the one order. So, Joy, since you did say something, hello, would you maybe like to just talk through your ideas about how might we try connecting those?
So the way I think about it, since we're only putting one order, so there would be one order number, and like say Alice, Bob, and I don't forget what the third name is. They'll have this. They'll their ID number will correspond with the same order number.
Okay, gotcha. So where would the order ID or the order number go? Would that go in customer or in order?
That will go in customer.
Okay, cool. So yeah, let's say this is like order number, and then the order number would relate to this guy. So why would this work? Well, one, Joyce, thank you for the answer. So let's talk through why this works. So if we have, let's say, a customer, and we'll say that we have customer has ID 1, their name is Alice, they have some email, and their order number is, let's say that they don't have an order number yet. So let's also say we have another customer, Bob, and we have like Charlie. Now, all 3 of these people are all going to order, they're all getting like one giant pizza. So we'll say this is like order number 1. It was like placed now, and what they're ordering is like one giant pizza. So what we can do using the schema that Joyce mentioned, we can say that, hey, let's give all of these guys the exact same order number. So Alice gets order number 1, Bob gets order number 1, and Charlie gets order number 1. That way, it says, okay, all 3 of these guys have all ordered the exact same thing. So we can have many customers making the same order. So we can draw a direct contrast between this setup, which puts order number in customer. We can contrast this with the setup that we just came up with here, which has many orders for a single customer. So you can have, let's say, me being like the customer with ID number 1, and I could have, let's say, a pizza that is related to customer ID 1. I could have I don't know, pasta that's also related with customer ID 1, and so on. And that relates multiple orders to one customer. So the way that I like to think about the many-to-one relation, setting up a many-to-one relationship, is you take the thing that you have the many for, and then you put the thing that you have the many for, take the ID of that and put it into the thing that you're taking a 1 of. So like in this, or sorry, other way. So in this case, like you have one customer being related to many orders. So because you have one customer, the one customer means that each order is related to one customer. So we say each order must have a customer ID. At least that's the way that I usually like to think about it. So you can do the same thing the other way. If we have many customers making one order, so we'll say one order. So that means that each customer has one order. So that means each customer has an order number. Did that help at all, or did that increase confusion about many to one and one to many relationships?
I think it helped me. I guess what I'm also trying to understand better is, so the class or the table with the many is the one that's going to have like the ID that connects both tables together. Is that usually the case? Like in the original example, since we have a single customer to multiple orders, we want to place the customer ID in the order table to connect it and not the other way. Or will it really affect it if we put it the other way?
So if you put it the other way, then it'll do what we did over here. So if you put the order ID in the customer, then it'll say that each customer has one order. So we can have one order belonging to having a bunch of customers. But if you put the customer ID in the order, then it says, okay, one order has one customer ID. So that means we can have one customer has many orders associated with it. So where you put it will alter the direction of that many to one. Is it many orders to one customer or many customers to one order? And all of that depends on whether you use customer ID or order ID.
Okay, sounds good.
Can you kind of like explain it, taking a DoorDash, for example? I am one customer. I have multiple people in my house. Maybe we want from two different restaurants, right? So there's like restaurants, it's a category, or I guess a column, and then in that restaurant I can order different items. It can also happen that I am done with my order and someone said, hey, can you order this from that same restaurant? And that is a different order. So you have items, you have restaurants, items, and orders, right? Like maybe like what's the one-to-one, one-to-many in a scenario like that?
Good question. And you know what? That's actually a really good example. So why don't we talk through it? So let's go. I'm going to make a new paint window if it will work. And okay, let's go with Harry's DoorDash example. So DoorDash. So let's just keep it really simple. So let's say that we have like a bunch of people in a house getting food from a bunch of different restaurants. Right? So you could have like, let's say I want to get food from from like McDonald's and Pizza Hut. Somebody else wants to get food from like just McDonald's. A third person wants to get food from like a third place. Is that sort of what you're thinking through, Harry?
Even to keep it simple, like one user is ordering, right? Like, so there's one ID for that user, and that user now is going to interact with two restaurants, and in those restaurants they might choose specific items and finish an order. Maybe they forget something, they have to do another order, and then they have to create another order with different items from a restaurant, right? Like just even one person can interact with so many places in the database, I guess.
Yeah. So I mean, for that, that is a little bit of a more convoluted case, I suppose. But what I would say is like each user has some relationship with orders, and then the order is related to a restaurant. I don't know if that really answers the question, does it? Okay, I'm gonna assume maybe. So if it doesn't, if you guys have further questions, though, feel free to let me know. But in the meantime, we're gonna keep trooping forward with the example, and then after that, you guys can move on to designing the Grubhub schema. Okay, so let me go ahead and clear some of this stuff out. So we don't need that. We'll keep the notes. So, okay, so before we talk about, so we've figured out how to relate customers to orders, right? So we have like, I can order like 15 dishes, but there can't be like 5 people order on the exact same order. So what next? We still have 2 tables that are floating around in our grand void. We have dishes and prices. How are dishes and prices related to either customers or orders? So let's start off with dishes. What table, how do dishes fit into customers, orders, prices? What's up with that?
It's each order can have multiple dishes.
Does that sound like it makes sense?
Yes. Yes.
Okay, let's assume the answer is yes. Let's assume that each order can have multiple dishes. Okay, so can one dish be on multiple orders?
Absolutely.
Okay, so what it sounds like to me is we can have, let's say, many orders having the same dish, but we can also have many dishes belonging to the same order. Hey, this is weird. So it's kind of like we're like putting a many orders to one dish, but many dishes to one order. That is where the magic of our many to many relationship comes in. So what we can now have is many orders relating to many dishes. And that is where the many to many stuff happens. So if you think about, like, the way I like to think about things is like, okay, you have your 2 tables. We need to relate these somehow. Can there be one thing from this table related to one thing from that table? Can there be many things from one table related to one thing in the other table? Can there be many things in that table related to many things in the other table? If the answer to any of those questions is yes, you have the relationship that you need. So we now have found out that we need to use a many to many relationship. So how can I write that out?
Umar, are you asking how would you create a table that would have like several dishes in it that you could then serve to like each customer or order? Is that what you're asking?
I guess I'm asking, how do we create the many to many relationship between orders and dishes? So for a many to one, we talked about how you link the IDs. Can we do the same thing with a many to many in the same way? Or do I create that differently?
You can add a dish ID to order and then reference it to the dish ID.
Okay. But then that would only create a many to one relationship. It wouldn't do it the other way, right? So if we created, let's say, if we added, let's say, a dish ID, if I understand what you're saying, Chris. So if we create a dish ID, then that says that one order can have one dish, but that many, or sorry, wait. Yeah, if you do it this way, you're saying that one order only has one dish belonging to it, but one dish can be in many orders. Because think about it, you can have like 3 different orders that all have the same dish ID, but each dish is only going to be related to one order.
Yeah.
So how do we do so like the schema that you have right now knocks off the first option, right? It knocks off many orders having the same dish. How do we do the reverse?
Do you need like a table kind of in between the two tables?
Yes, exactly. So what we're going to need for a many-to-many relationship in SQL is basically like a go-between table. And let's think about why. So let me put dish ID back. So if we wanted to do many orders having the same dish, we can do exactly what Chris said, is put our dish ID in order. So that works. And at the same time, hypothetically, okay, well, we know that, we have the first one, we have many orders having the same dish made. So you know what? Let's take our order ID and put it in dish. So we'll put order ID in there. And then that way, this guy goes here, so we can cross off our many dishes belonging to the same order. Does anybody see why we might have a problem here?
Yeah, it still doesn't take care of it like it should with the dish thing. Because
That's one problem.
it can only reference one dish ID, even
Right.
if the order has multiple dishes.
Yeah, so that's half of it. The other half is if I give you if I tell you to go to a specific order, that order is linked to a dish. We go to that dish, and that dish is linked back to the same order, which is linked to the dish, which is linked to the order, which is, basically what we'd be doing is if I told you, hey, go to the specific order, we would be going from the order to the dish, we'd be going here. Oh, okay, from here, I need to go get the order ID, and then we'd be going back here. And you basically will just get a infinite loop of going between orders and dishes in the setup that we have right now. So we can't just say that the order has a dish ID and the dish has an order ID. So that's the reason why we need the intermediary table that I believe it was Tyler suggested that we include. So let's go ahead and make an intermediary table real quick. So we have, well, let's call it like order dish. And the only purpose behind this table is to link our orders with our dishes. How can we link our orders with our dishes? Well, first, we're obviously going to need to give our table an ID. It needs its serial primary key. And then we can just say that we're going to have a field for the order ID and a field for the dish ID. So this guy goes in here, this guy goes in here. And this will fulfill our many orders to many dishes. Why does this work? Well, let's say that, I have, let's say I have 1, 2, 3, 4, let's say I have 5 orders and I have, let's say 5 dishes. I'll have 1, 2, 3, 4, 5. So by using this little go-between system that has a table in the middle, I can say, using this, hey, I need to create a relationship between order 1 and dish 1. I also need to create a separate relationship between order 2 and dish 2. I also want to create a relationship between dish 2 and order 1, etc. And so by creating this entirely separate table for our many-to-many relationships, we can relate the IDs as we want to. So we can have many order IDs linked to many dish IDs and vice versa. So that's really where for a many-to-many, we need to use a new table to join/combine, or I guess to relate the IDs of the many-to-many tables. Does that make sense? Are there any questions about why we need to create the new table to do this? Okay, so we're now going to move on to the last part, which is going to be how do we connect a dish to a price? And then after that, I promise we'll be done. So how can I link a dish to a price? What relationship do they have? I guess a category.
Could this be a one-to-one?
Say that one more time.
Let's say, could this be a one-to-one? Like each dish has a single price.
You could say that, yes. It could be one-to-one. But let's say that you have a lunch menu where everything is $15.99. Then we have the exact same price for a bunch of different items. So would one-to-one necessarily work there?
No.
So what might we want to consider instead? Here, I'll change price to category instead. That would probably a little bit better.
Be a one-to-many.
Okay, one-to-many. So Chris, since you volunteered the answer for that, how do we connect our dish to our category? So let me ask you first. Does one dish have many categories, or can one category have many dishes?
Many dishes can have one price.
E? What do other people think about that? So also let's forget about price right now. Let's just call it category. Just to keep things a little, I think a little bit simple.
Yeah, category can have many different dishes. I guess a dish can belong to categories too, though.
Yeah, I guess it could, but for simplicity's sake, which is important when we're doing SQL, let's just say that a category can have many dishes, right? Because if you think about it, like if you look in like the appetizer section of a menu, the appetizers are a category, and the appetizer section of your menu has like 10 different dishes inside of it. So there's many dishes belonging to one category. But you usually won't see, well, you might, but usually you don't see like the same appetizer, like an appetizer also being like a drink or a dessert. Like that doesn't really make sense. So what we could have is we can say that there's many dishes in one category. So if we have many dishes in one category, how can we what do I need to write to put that relationship in SQL?
You would reference the category in the dish was
Okay, so we could write, let's say, category ID here, And then we can draw our little arrow to show how these connect up. So why does that work? Well, I can have, let's say, 3 different dishes. Let's say I have a pizza dish, a pasta dish, and like a burger or something. And all 3 of those dishes can now be related to the same category ID. So that says, like, let's say it's like a main course. Well, the pizza is going to be in the main courses. The pizza has a main course ID associated with it. The pasta has the main course ID associated with it. And whatever else I said has the main course ID associated with it. And they can't have more than one. So that's how we can put many dishes in one category. And that's it. Our schema is basically done. So to recap where we started and where we are now, you can have a customer as our base class. Then when we move over to our orders, we're saying that there's many orders belonging to one customer. So we put, because there's one customer for many orders, each order is related to one customer. So each order has a customer ID. So we can put the customer ID in the order, and then that links customers and orders together. Then for orders and dishes, many orders can have the same dish in it, but many dishes can have the same order. So we need to create a many-to-many table. And the only way to do that is creating a brand new table, which we called order dish, to link orders and dishes. And the last thing we did was create many dishes going into one category, right? You can have many dishes being appetizers, for example. And in order to do that, remember that we have one category. So each dish is related to one category. So each dish has to have a category ID. So if we want to draw the directions of these arrows a little bit better, that might be a better way to do it. And yeah, that's basically our finished schema. So that's all I've got for lecture material for today. There are, some things that we can talk through regarding how to write queries and how to turn this into SQL implementation, which is in the README. But are there any questions about anything I just talked through?
Yeah, so if you were to add the total up, you could do that in the order, right? And then reach into the order dish and add the sum of dish IDs all the way down to the pricing category. Is that how you would do that?
So like the total of like one specific order?
Yeah. So yeah, the total of the order based on how many dishes have been ordered.
So what I would probably do is first go from order into order dish, and I would say, hey, in order dish, get me all of the dishes that match up to my order ID. And then for each dish, I would use that and then get the category associated with each dish, and then just sum those all up together.
Cool, that makes sense. Thanks.
Yeah. So it's like the slightly annoying thing about the many-to-many is you always have to go through that connector table. But so that's the one thing I would caution. Any other questions about this example? Or about one-to-one, many-to-one, many-to-many relationships? Okay. If not, I'm going to stop the recording.